All right, so now we're going to move on to lab 3. This is going to be where we make our displacer crank. And before we begin, we're going to want to look at our working drawing, and we're going to want to try to get a picture of the model in our head. Try to picture what it's going to look like as if we were holding on to it in our hand. It helps that we have this isometric drawing here, so we can have a better view of it. We want to look at the views that we have, and we want to kind of start to get an idea of how we're going to model this. So we want to have a game plan before we start to model. We don't just want to start making sketches and extruding things and just, I'll figure it out as I go. We want to have at least some sort of plan of attack. So when I look at this, I see this top view here. I see that it's pretty descriptive. We have a lot of information here. And I can see that we've got this 1.24 inch diameter. So I know that this circle here is 1.24 inches. And when I come down here, I see that we've got this arc right here. And so I can see that this is a continuation. So I immediately think, well, that's a circle. But we've got a couple of cutouts here. So I can start to picture, okay, I'm gonna draw a circle, and then I'm gonna cut these parts out. And then I'll extrude it. Looks like we got some holes. We've got a hole at the top. We come over here to this section view. This shows us the inside as if this was split down the middle. That's what the A and the A are telling us. So section AA, that this was cut in half, and we're looking at the half right there. We can see we've got this hole right here. And then we have a chamfer going around the entire part. So let's go ahead and open up NX and start this model. So be sure that you are in the advanced role, and we're going to go to new. We want a model, make sure that we're in inches, and we're going to name this Lab 03A. So we're going to model this, and then we're going to create a drawing of it. So there are actually 3 things that you need to submit for this lab: the drawing, the model, and then we're going to use the master model approach to make the drawing, so that part file as well. Make sure you save this to a place that you can access, and we'll go ahead and start. So like I said, we're going to start with a circle. So we're going to go to Sketch, and we will start this on the top view. Make sure our circle is at the origin. And we're going to dimension this 1.24. And I'm going to come up here to Profile. And I'm going to do a similar approach that we did before. So I can come up here and start the line on the arc right here, or I can just cut across, make sure this is a horizontal line, and then come beyond the circle, make sure that's vertical. We're going to come up to trim and trim the excess lines. And we also want to trim this section of the circle. That's going to make our cutout right there. We're not going to do it on the other side, because what we're going to do is we're going to mirror this. So when I looked at the part, I saw that this side, our right side, was the same as the left side. So I know that if I draw this, I can just mirror this to that side. And save some time, so I don't have to draw these lines, dimension anything, put any constraints on here. I can just dimension one side and mirror it. So what I'm going to do is I will dimension this line from the horizontal axis. That is 50 thou. And then dimension this line from the vertical axis. Now we're told from the left side to the right side. And we're told that is 0.312. So from this side to this side. So from the left side to the center would be half of 0.312. So we can put equations into our dimensions right here. We don't have to do any math. We don't have to pull out a calculator, find out what half of 0.312 is. We don't have to put in anything that we don't already know. What we can do is we can say equals 0.312 divided by 2. And when we hit enter, we are going to get half of 0.312. This is helpful because, well, A, we don't have to really think about it. Just, okay, well, that's half of 0.312. And then B, if anyone ever comes back and tries to edit this or needs to edit it for any reason, they'll actually be able to see that the calculation that we put in of 0.312 divided by 2. And they'll be able to understand that, oh, well, they're actually seeing that from this side to the right side was 0.312. They were dimensioning it from the halfway point right here. So that's why they did the 0.312 divided by 2. Just a way of having our steps documented. Our sketch is fully defined, so what we need to do is come up here to mirror. We want to go to settings and make sure that create persistent relation is turned on. And then we also want to make sure that we are doing single curves. If we do connected curves, then it's going to select everything. What we want is just these lines right here. If you did select all the lines, you don't have to exit out and restart or anything. If you hold down shift while you click on what you want to unselect, it will unselect that object for you, or those lines or anything. So if you accidentally clicked on something you didn't mean to, just hold down shift and click on it again and it'll unselect for you. So we're gonna go to single curve and select these two lines. Our center line is going to be the vertical axis. And you can see that we have these two lines over here. We'll hit OK. Come back up to the trim and trim away that excess part. Now these two sides are exact mirror images of each other. So if we make a change on this side, so let's say this was 60 thou, it's going to make it to the other side as well. Now we can hit finish. And we can go ahead and extrude this the 0.32. I'm going to extrude this so that it's symmetrical, so that our origin is still in the center of the part. So we can go to extrude. And we want symmetrical value. So instead of value, so where it says start, we want to go to symmetric value. And this should be 0.32. Remember the old NX, which you may come across at some point. This value here was saying from the midpoint to the edge. So this would need to be half of 0.32. They've changed it recently so that the distance that they're talking about here is from one side of the model to the other. So this is the total distance, not the distance from the sketch to the edge. This is the total distance. So we want to put in 0.32 and we'll hit OK. So we've got the basic shape. We have the thickness. Now let's look at these holes that we have. Let's do the first one, the 0.125 inch through hole. This hole is at center, so it's going to be right where that origin is at. All right, so we can go to the hole command. We want a simple hole, going to be 0.125 inches, no start chamfer, no end chamfer. And when we specify the point, we're going to create a sketch. And I want the sketch on this top face, so the face of the extrusion. And we'll hit OK. And then I want the point to be at the origin of our model. If you cannot access that datum, make sure that you are the filters. Make sure you are in entire assembly. This is going to allow us to select objects and points that are in the assembly. If we're within active sketch only, see how I can't find that origin. It won't let me select it. It's because it's not on the sketch plane. It's below it. But if we go to either work part or entire model, see how we can access all these different points now. We go to entire model. Now I can actually put the point at the origin. So when you do origin of datum coordinate system, and we'll hit close. Sketch is fully defined. We'll hit finish. And this is a through hole. So we want to do through body, and we'll hit OK. Now we can do this M3.52B through hole. This is a metric threaded hole with a countersink here. So we're going to go back to the hole command. This time we're going to go to threaded. We want an M3.5. So M3, that's metric. If you're not sure, where that M3 is, you're not sure if it's coarse or fine, just click on one and see if it's there. And if you can't find it, try the other. We got an M3.5 here. That's a metric coarse. Radial engagement, we just do the 0.75. Thread depth type. This is going to be full thread. We need a start chamfer here. And when we specify our point, again, we're going to go to a sketch. Select the top face. We just want to click on a point here. So just put it down here somewhere. And if we look at our drawing, it's on the same vertical line as the origin, and it is 0.269 inches below it. So what we're going to do is we're going to put a constraint on here that is going to constrain this point to the same vertical axis as the origin. So we come here to make vertical. So we're going to do a make vertical constraint. And I'm going to select our point that we just made. And then I want to select the origin, but I can't select it right now because of my filters. So I'm going to come up here and I'm going to go to within work part only. And now I'll be able to select that origin point. That's what I want. And I'll hit OK. And so now it's constrained to that on that y-axis. So I won't be able to move this left and right. I can only move it up and down. So it's always going to be on that axis. Now I want to dimension this the 0.269. So it's 0.269 inches down. So I will click on that point, and then I will click on the origin. And we'll do 0.269. Again, if you cannot select that origin point, make sure that you are either within entire assembly or within work part only. It won't work if you're within active sketch only. The sketch is fully defined. We can hit finish. We want this hole to be a through hole. So at limit, we don't want a value. We want to do through body. And we will hit OK. Got a chamfer, and we have threads. And I think we'll be good with that. Now on this third hole that we have a counter bore here, and it's at diameter of 0.188. And we have a thread. It's a 632 UNC. It has a depth of 0.62 inches. The counter bore has a depth of 0.38. And then the entire hole itself has a depth of 0.75. So let's go to NX and make this hole. Now the hole is up here, and we don't really have a surface that we can just put a hole on. So I'm actually going to go back into the first sketch, and I'm just going to put a point at the top of this arc that we can then click on when we are in the hole command. So go back into sketch 1, right click, edit with rollback. And then I want a point. Now I'm just going to put it somewhere on the arc. Oop. Then I'm going to do another make vertical between the point and the origin. Hit OK. Now you see that it's right there. Sketch is fully defined. Hit finish. Now we've got a point right at the top of that arc right there. We go to hole. And what we want is a threaded hole. And we're going to do the 632. So that's a UNC, a number 632. Our radial engagement, we want custom. But we're going to keep the drill diameter what it is. Our thread depth type, we also want custom. And we want our thread depth to be the 0.62. Under relief, we want to apply the relief. The relief is going to be our counter bore. So we'll do 0.188. It has a depth of 0.38. And we're going to turn off this relief chamfer. And make sure there's no end chamfer on there either. Our limit is not going to be a through body. We're actually going to put the value of 0.75. 0.75. And we can go ahead and specify our point. Now we specify our point, we're going to click on the point that we just made at the top of that arc. And we can go ahead and hit OK. Actually, let's go ahead and hit show results. Just to see if that looks about right. And that looks good. We'll hit OK. And we can verify that going to view, edit section. And that looks pretty good to me. Go back to clip section. We're not quite done with this yet. So we have a couple of radii here. So these are not sharp corners. These are actually have a fillet to them. We could have done this in the sketch, but we can use a command outside of the sketch to help us get these radii. And then we also have a note down here that says break all edges with a 0.2 by 45 degree chamfer. So the first thing we're going to do is put these radii in. These have a radius of 0.06. And that command that we're going to use is called edge blend. So edge blend has face blend and edge blend. What we want is edge blend. The radius that we have is a 0.06. And we're just going to select the lines that are going from the top face to the bottom face right here. And then also on this side as well. We'll hit OK. Now let's say you only did one side. You don't want to select another edge blend. What you would do is you would go back into the edge blend that you created and select the lines that you need to have the edge blend. The only time that you want to create another edge blend is if you have one that is not the same radius. So we don't want to have like 30 different edge blends if they're all the same value. Now we want to do a chamfer on all edges. So we'll do it around the face of the part and then also on the corners as well. So we'll go up to chamfer and we got a 0.02, so 20 thou chamfer on these and start clicking on lines. Sometimes they will actually connect and then they'll just stop. So you kind of just got to keep on following it and selecting the lines as you go. sometimes the order plays a significant role as to how the part looks. So if I had done the chamfer before doing that fillet, then this would not be correct. It would not look right. So the order of operations as far as like chamfers and edge blends go, it is important. Hit OK. Double check that we got all of our corners. And of course, we want to make sure that we tidy everything up for our drafting. So we're going to put our sketches and our datums onto layers. So we're going to go to move layer, move to layer, go to our filter, select datums, and then we will select all. We'll hit OK. Select the datums category, hit apply, select new objects, go back to our filters, go to sketch, hit select all, hit OK, and then sketches, and we'll hit OK. And go to the layer settings, and we want to unselect the datums layer and the sketches layer. Now we don't see our sketch, and we also don't see our datum right there. And then in the next video, we will get into the drafting.